Muted. Okay, so I'll keep going. So I'm talking from Recife in Brazil. It's in the Northeast. It's pretty hot in here. It's like
Yeah.
making 90 Celsius right now. I'd say not 9 Celsius, 90 Fahrenheit. Fahrenheit. So I'm graduating in computer
Mhm.
science, and I used to work with Django and React. I've been working with Django for the last 10 years.
Mm.
Uh,
Mhm.
so
Okay.
and I'm also music producer in the free time. So if you wanna hear from my songs, it's on Spotify. You can just look for Django Boston on Spotify, and you find some of my tunes. Okay. Uh, and I'll start this by talking about Django. So Django, I love these slogans, like it's a framework for perfectionists with deadlines. I love that it has batteries included. So many things like security, authentication, authorization, administration, and a
Sete,
very
você
robust and mature
introduz,
RM.
começa aí, se
Uh,
comanda, tá?
sorry.
Keep going, Hugo. I think when people come online, they're not muted, so I just muted them.
Okay. Okay. Basically, it has a lot of batteries included. You can do many things just by installing the framework. There's a lot of things it handles for you, don't have to worry about. It's also very opinionated. It defines the right way of doing things. It gives you a path to follow. And this opens doors for building extensions. So there's a lot of plenty of packages that can be used for extending Django behavior because it says what's the right way to do things. You can build on top of it. So you have a lot of packages that includes models, includes like database behavior, and strong configurations. And it also has a strong community, a lot of open source packages, events, meetups, and active development. Even after 18 years of development, it still has interesting features coming out every year. So Django is a great tool to work with, right? But it has some downsides. Django's performance, it's a thing, right? If you're not careful, it may drag you. It may create issues for your product. So there's a lot of things you can do to handle this properly. You can avoid N+1s. Django is very prone to, like, it makes it really easy for you to add N+1s to your application. You can do caching. You can do database indexing. You can do data denormalization, and you can run operations in the background. That's where I'm going to focus more in this talk is in the fifth point. And to explain why this is important, I would like to have a look at the Django architecture of a Django server, basically. Django is kind of wrapped in a WSGI HTTP server. There are many options in there. There's Unicorn, there's UWSGI. There are things that different servers you can use to wrap a Django process. And it basically creates multiple processes for Django. And it has a load balancer that kind of assigns a request for each of these processes that are running in parallel. So what this means basically is each Django process loads the full framework, or at least some big part of it into memory, which makes it expensive to have too many processes, right? Because each of these processes consume a fair amount of memory. And basically, each process holds a request. Basically, if your request go to your server, it basically is assigned to a Django process, and it's this process is kind of dedicated to that request while the request is being processed, right? Which means we need to make sure our requests are processed quickly so we don't hold this process for too long. And also, another reason for running operations in the background is that we need to give feedback quickly to the user, right? We don't want to get our users waiting for a long request to be processed, because that, like, there are many studies that says that users, the engagement of the user depends a lot on how much time it takes for each operation to run in a software, right? So the engagement is highly impacted by the feedback time, the time for the server to give you a feedback. So Celery is a great tool for doing that. Like Celery is basically a asynchronous task queue or job queue, which is based on distributed message passing. One important keyword here is that Celery is a kind of a distributed system. It runs separately from your main application, right? It is really fast. It has like small boilerplate. It executes, like, it has very low memory consumption, and it's very integrated. Like, you can integrate Celery very easily with many different Python applications. And the integration includes like access to models, services, functions, everything from your original application, right? Your main application, your web application, right? So it's very integrated with many tools. But like, Celery especially loves Django very much, right? You have dedicated documentation for Django. You have Django settings integrated with Celery. You can define Celery settings through Django settings as well. You have access to Django RM and other tools through Celery tasks, so you don't need to connect to your database with a different tool. You can use the same tool that you use in your web application to connect with your data. And the community is very strong as well. There are plenty of packages to upgrade this integration, to add behaviors, to add monitoring, to add more tools for you to use them both together and in a healthy way. Okay, so and how does it look like? Like, basically, with Celery, you define a task, right? It's basically a function. There are other ways to define tasks. You can use like a class. You can inherit from a class. But with this decorator here, you can define a function that receives a list of parameters and executes something. In this case, I'm getting the user with this ID, and I'm running a slow operation to calculate the user score. So this operation is slow. I don't want it to freeze my request time. So I don't want to get too long to respond to the user during the request. So I put this into a task. And in my view, my Django view, I basically will call this task and will not wait for it to finish before I respond to the user. So this delay method here I'm calling, it basically starts or sends a message to start the task, and it just goes straight to the next line. It doesn't wait for the result. So I'm basically running this operation in background. This is how it looks like at first, a Celery integration with Django. These ellipses here basically are settings you can import from Django settings. So I didn't include the settings here, but it's basically some initialization configuration, okay? And what the sync task can be used for? You can delegate long-lasting jobs. You can execute remote API calls. Like remote API calls, you don't know exactly how much time they're going to take for responding. Some APIs may be slower, or they may go through a peak and take in a specific moment they can be slower. So it's good that you execute outside of your request time this remote API calls. You can prepare and cache some values. that are not that don't need to be async like in the exact moment they change, something changes. You can use Celery for that. You can spread book database insertions over time. Maybe you don't want to overload your database with multiple insertions at the same time. You can create a slower pace to not overload your database. You can execute recurring jobs. There are many cases that async task can be used for. But under the hood, how it works, right? It's like this code is pretty simple, but under the hood, it's not that simple because, as I said before, Celery is a distributed system, right? So what happens under the hood is Django uses a Celery client to connect to a broker and to send a message to the broker saying they want something to be executed, right? So Django process sends a message to the broker, to a queue. Celery is always watching, your workers are watching this queue. They mark a task as started, they pick a task, and so other workers don't pick the same task. And after they execute the task, they mark the task as succeed. This flow may vary a little bit because of some settings. There are some settings that can modify when you mark a task as picked, when you mark a task as succeeded, like if it's before you pick, if it's after you finish, there's configuration to change this behavior, but this is the main flow. And that's not the only thing, right? After you finish a Celery task, you can respond with something, you can return some data. And basically, there is a result backend that receives, it's kind of a database that receives these results from Celery, and Django may read these results or not, right? If you care about these results, which is not always the case, you can read it from the results backend through Celery as well. For instance, in this code I showed you, if you wanted to wait for something that this function does, this task does, you could just add a get here, and you would be able to get these results immediately, but that wouldn't save the time, right? It would just save the resources. This code would be executed in a separate process, but we would still wait for it to finish. So usually, I wouldn't say usually, but many times you don't want to wait. So this results backend is not always useful directly, but it exists. You can use it if your task requires it to get some results. So it's not that simple, right? It has a lot of infrastructure involved. It's a lot of messages being sent from one piece to the other, one part to the other, one service to the other. And that's why I say the love between Celery and Django is a tough love, right? It's not specifically about Celery in Django, but it's because of this Celery being a distributed system. It creates a lot of complexity that may not always be clear, that it's not always clear, it's not always wanted. So you need to consider that when you're using Celery in Django application. I would say like the love between Celery and Django is kind of a non-monogamous relationship, because like sometimes you get like some concurrency surprises, right? Concurrency is the key word here. Working with concurrency in this case makes things a lot more complex. I have some examples of things that can happen, some issues that can happen when you have a Django and Celery application. Things may fail, like in many of these connections. Like concurrency becomes your worst enemy. You have tests that will never finish. You have outdated data. You have queues, unbalanced queues. You have duplicate runs. There are many things that are not exactly a problem with Celery or a problem with Django, but it's just a condition you have because of the how these things work, right? So you need to be very careful. In this talk, I'm going to focus on these 4 points. right? Because I cannot handle all the problems you may have with Django and Celery in that short of time. But I'm going to talk about these 4 issues that are very common in Django Celery applications, right? The first one is outdated data, right? Sending complex data parameters to Celery may be a shoot in your foot, right? Because when you send, for instance, in this case here, you send a user to a task. This task, you don't have no guarantees that this is going to be executed in the time you call it, in the time you message the broker saying you need it. So this user may change in meanwhile, right? This user object may be outdated. So ideally, instead of passing a complex object, you should pass a identifier so your Celery can get the most up-to-date version of the object before they start doing some processing. Otherwise, I may have like conflicting operations, so and outdated data, right? You can use like a field from user that is not anymore it doesn't hold this value anymore, basically. So this is something you have to pay attention to. You cannot send complex objects to Celery. Usually you send an identifier and you get the value, the current value from the database whenever the task starts, okay? Another thing that's pretty common is duplicate runs, right? There are many cases that may make your task run twice or multiple times. Because like, for instance, if a worker picks a task and another worker tries to pick the same task at the same time, this is some of the brokers handle this case. They are kind of atomic in this case, in this scenario, but this is something that may happen sometimes. So these 2 workers are going to execute the same task at almost the same time. So you have another way to have this is if a task is interrupted by some server failure. Let's say your machine is restarted and you are not able to finish the task. You may have to rerun that task, but you may have run it not entirely, partially, right? So you have to make sure that you have atomicity and idempotency in your tasks, right? Here in this example, I'm receiving a user ID here, but I'm not just picking the user. I'm getting the user that has a outdated score, right? I check the last order and I see if the last order that was used to calculate the score is equal to to the last order, right? So if the user is outdated, it's going to return. If not, I'm just going to end the function early, right? This is going to return none, and I'm going to end early. I'm not going to run this whole operation here. This makes sure that if this function is run twice, the second run will not pick the user anymore and will just cancel. It will not affect the data state, right? So it kind of make this operation idempotent. You can run it multiple times and it won't have any, just the first time has some effect. The following ones won't have any effect on the data, right? The end result will be the same as if you run only once. And it also has atomicity. So using this decorator here, which is from Django, I ensure that any database operation that runs here is undone if something fails. If something in this function fails, I'll undo everything on my database. This makes sure that like if I run this function partially and I don't save the full object, I don't adjust the object exactly as I want to, I will undo everything. And if I run again, I'll have the database with the previous state as before the first run has partially run, right? So Another common case is error feedback, right? Error feedback, it's kind of more complex when you have async operations, background operations, because even though you give a quick feedback to the user by the server, the server responds before the full operation runs, the operation can still fail, right? You can have some bug in your task that kind of destroys your data or kind of makes your data wrong. It makes wrong operations to your data. And now you have to tell the user after they receive the success message that the operation didn't work correctly, right? So you need to take this into consideration when you're implementing a feature that involves a background operation. You need to store some sort of state, something that tells the user that the operation is not completed, even though he received the feedback from the server and the application. It may look that the operation has run fully. It's still going to have some operations running in background, and it still may fail. So you may also need to, for instance, if something fails and you partially did the operation in the server, if you do part of the operation in the web server and other part in the background task, if something fails in the background task, you may also need to undo the operations the web server did. So it creates some complex scenarios around feedback and state if something fails. And you need to take this into consideration, right? If things fail, you need to make it clear for the user that it failed, basically. There's also a problem with conflicting operations, right? I'll give an example here. Imagine a system that a user can add notes, the user can delete a note, and the user can also book create copies of a note. Assuming that this last operation for creating book copies of a note is slow, and you want to do it async, right? You want to do it in the background. You don't want the user to be waiting in the request time for the operation to be finished, right? So in this scenario here, the user creates a note. The user requests the book creation of 10 copies of the note. This runs in the background task. Before this task finish or starts, the user deletes the original note. And when the task runs, the original note is not available anymore because it was deleted before. So it cannot be copied. You don't have access anymore to the fields of the note to create these copies, right? There are many ways to fix this, right? You can just implement soft delete on the node, so it is available even after the delete operation, right? It may look for the user that the node is deleted, but the database still have the data, so it is copied after. Another thing you can do is cancel pending task before deleting the node. So Celery supports that. You can cancel pending tasks. So you can just like, if I'm deleting a node, I'll cancel every task related to deletion of to copies of these nodes, right? And another thing you can do is just lock the node. Create some sort of state in the node model to store if the node is kind of locked. If the node's locked, the user won't be able to delete. It may show in the interface, for instance, that the node cannot be deleted because there are pending operations on that node. So there are pending copies, copy operations on that node. So you cannot delete it yet. So locking might be a good solution here. So I showed you a lot of problems that can happen between Django and Celery, right? There's also like couples therapy for that, right? There are some tips that help the relationship to flow between Django and Celery. For instance, retry tasks. You can, this is a common pattern. Like if you're for instance, accessing an API in a task, you may want to do it multiple times because the first one may fail because some intermittent issue on the API side. So you may want to retry. It's recommended to use exponential backoffs on retries, so you don't try multiple times too quick, and don't wait for like enough for the API to go back live. So exponential backoffs are built-in, are included in Celery. You can use just a setting in the task decorator explaining that you want to do retries, the amount of retries you wanted to do, and also the backoff between the retries, the backoff function. Also, tasks shouldn't raise exceptions, right? Unhandled exceptions. This may create issues on Celery management. It may not be clear, for instance, the stack trace of the exception for you. So one recommendation I do is always handle exceptions and send reports in case you cannot treat it like automatically. If there's something needs some manual work, you need to send some reports somewhere, some logging tool like Sentry or Datadog. You can create some alerts and receive an email when you have some unhandled exception or unweighted an exception you're not waiting for. But I don't recommend like having wild exceptions being raised into your tasks. This may create some issues to investigate the problem, right? Also, monitoring is essential. There are not many good tools for monitoring Celery, but as it is a complex piece, right? It has a lot of moving parts in a Celery infrastructure. It's good to have at least a Celery Flower instance connected to your Celery application, so you can at least see what's on the queue, what's running right now, how many workers you have, how healthy the workers are, how full the queues are. These are all informations that can be seen in Celery Flower. This is a web application. You can, there's also like, it's Dockerized, so you can use Docker to deploy a infrastructure with Celery Flower running, connecting to your Celery infrastructure, and giving you some insightful information, right? For development, I recommend using Always Eager, not only for development, but also for debugging. This basically makes your tasks synchronous. So whenever a task is configured as Always Eager, it will just run when you call it. It will not send a message to the broker. It will just run the code, and that can make it easier to debug, right? You don't need, for instance, in development to run a full Celery setup with many workers and like multiple machines running, multiple processes running at the same time. By using Always Eager, you can debug things just by running your web server, right? It makes your memory consumption a little bit smaller in development, for instance. Another tip is using RDB, which is a remote debugger. It basically opens a connection, a socket on your Celery or whatever, a remote server. And whenever it hits the set trace, it will freeze and open this connection and open this port. So you can connect from your local machine and look at the state of the application, right? So RDB might be a good tool for you to debug things in production or even locally without Always Eager by running the actual workers. RDB may help you to find out what's wrong and look at the state of the function that's not working, for instance, that you want to investigate, right? Look at local variables and everything, okay? And state in general. All right, I also recommend looking at Dev Checklist. This is a website that Vinta has set up. This is open source, so if you have checklists, you can also contribute to this. but we have one specific checklist about Celery tasks. It basically gives you some good practices while defining Celery tasks. So if you are setting up Celery in your application right now, you can use this to check if you're doing everything with the best practices, right? So that's it. Here's my email. Thank you for listening. And if you have any questions, feel free to ask.
Hugo, I think there's one question in the chat, in the Q&A that somebody put in.
I don't know how to look at the chat with screen share. Oh, I found it. Okay. So let me see. I don't see any questions, only comments. Okay.
It's under the Q&A. It's the question is Celery specific to Django?
Oh no, it's not specific to Django. It is like specific to Python. So if you have a Python application, you can use Celery client to send message to a broker. The integration might be a little bit different because, as I said, Celery loves Django. There's a lot of tutorials and specific setups that works only for Django, but you can also use it on other application like Flask or Fast API.
Hugo, it seems. Oh, go ahead.
Go on.
No, go ahead. I'll wait.
I think there's some other questions here about Django Q. I don't know Django Q. I'm sorry for that, but I never used it. So do you want to talk a little bit about it, William?
I think I haven't used it a ton myself, but I know Jeff Triplett, who's on this call, and Carlton Gibson are huge fans of it. I don't know see if I can get Jeff to say some words. He was actually just working on something right before this. I think they find it just to be a little bit simpler. And so if you don't need all that Celery provides, it can work in that case.
Yeah, I hope it is, because like Celery adds a lot of complexity into the sauce, right? It has a lot of points of failure. So simplifying, if you don't have like the extreme need of like a distributed system or something that involves a broker, it may be a lot simpler to use for simpler use cases, right? Raymond asked me to talk a little bit more about the remote debugger. Remote debugger works exactly like a normal debugger for Python, like PDB, right? But instead of like just giving you input, like as it runs remotely, you are running it in a remote application that's not running on your machine usually. PDB doesn't work, right? Because you don't have access to a shell, right? An input to actually run the debugging, right? Look at variables, values, and etc. So what RDB does is basically open I think it's telnet, if I'm not mistaken. It opens a telnet port, and you can connect to your RDB kind of server and call commands like you would do into a normal Python debugger like PDB or IPDB, right? But you would do this remotely from your machine when the debug is running on another machine, a production machine or a staging machine, or even a remote development machine, right? Any questions about it?
Yeah, I just specifically like when I like if you just type in Python debugging RDB into a search bar, at least for me, nothing useful is coming up. So how do I install this? Is there a PyPy package? Is it?
I think it's built in. the RDB. I'm not sure, but I think it's built in the Python library. You just import it and you run rdb.setTrace, and it will basically freeze in that point in the code and open the telnet server.
Okay,
So-
thanks. Take a look around.
I can send you a link afterwards if that's helpful. I can put it into the end of the presentation. We are going to share these slides after, so I can add a link explaining this in more detail. Let me see if I have any other question. What's your favorite way to handle processes that don't finish in production? What do you mean by don't finish? It keeps running? Is that it?
Yeah, for example, it keeps running, or you know, if there, you mentioned like a multitude of things that could go wrong, right? So yeah, it doesn't finish, it keeps running. How do you detect that, and how do you properly manage that?
By default, Celery has already some, or at least if you're using with RapidQ, which is a common broker, right? A queue broker. It already has some sort of, it's already handled by default, right? It has some timeouts that if your task takes too long, it is queued, right? It is queued and go back to the queue. So it depends on your setup. You can configure this, but by default, it already forbids your tasks to take like 1 hour to run. I don't know exactly what's the default threshold, but it's already built in. You can you can just configure it to be longer or shorter, depending on your needs.
Cool. Thanks, Hugo.
Any other question? I think we're over time already, so you say it.
So thank you everyone so much. Thank you, Hugo, for this amazing talk and really thought-provoking. Yeah, so I think we'll adjourn at this point unless anyone has anything else to ask, Hugo.
Just one thing, if you have any other Celery questions or anything related to distributed systems or Django, I'm available at ADP list, so you can just book a session with me there, and we can talk about things like that. So feel free to schedule a session there. It's free. So I don't know if you know this website is for mentorship. It's called adplist.com. So you can just look at me there and schedule a session. Feel free.
All right. And with that, everyone, I think we'll adjourn here. Thank you so much. See you at the next event.